Okay, so this is one of the fundamental questions from chapter 22. So it basically gives you a bunch of different areas that encloses charges, and we're supposed to find what the flux is. So for an area that encloses a charge, the equation is pretty straightforward. It's the charge enclosed over the electric constant, and that's going to give you the electric flux through those areas. And if there's more than one charge, it's the addition of them, right? So the total charge is enclosed. My S1 is in green. My S2 is in not green, it's in red, and my S3 is in black. I have encircled them in colors, so I know what I'm looking at. So for my S1, there's a charge 1 and a charge 2 enclosed. So Q enclosed equals, this is supposed to be an equal sign, equals charge 1 plus charge 2 over my electric flux. My charge 1, they give it to me, is 5 microcoulombs, or 5 times 10 to the 6 coulombs, plus my Q2, which is -3 times 10 to the -6, which I have there, all over my electric flux. My answer to that is this, 2.25 times 10 to the 5th. That's the electric flux coming from there. Now, the electric flux coming from the second surface is Q3 plus Q2, all of this together. And that is 2 times 10 to the -6 plus -3 times 10 to the -6, all over the electric flux. And I get that. And then do the same thing here. My S3 encompasses all of them. So they should all be, they're all part of the equation. So Q1 plus Q2 plus Q3 over the electric flux. That's what I did over the electric flux. And I got that for my S3. Pretty straightforward problem. It's important to know. It's also important to note that if no charges are encompassed, then my electric flux is 0 because there's no charges encompassed.